we're students from the German University in Cairo. We're working on a Bluetooth controlled car for the embedded course. We are 4 students named Yusra Yusuf, Nada Abdelmanam, Abdurrahman Badr, and Ali Muhammad Yahya. We have 3 features in this car. The first feature is optical detection using ultrasonic sensors and a buzzer. The second feature is displaying the current temperature, current date and time, the gear state, and the night detection, whether it's dark or bright on the LCD. And the last feature is the sound systems. It consists of an MP3 player and a speaker, so you can play songs on the car while it's moving. We use free RTOS to schedule our tasks. They are all of the same priority and they are periodic. We also use semaphores in our third feature, which is the sound system features. And now my colleagues will talk about each feature.
Here I will explain first feature, braking system. I'm used 2 ultrasonic sensors to sense object, ultrasonic sensor mainly depend on trigger and echo. It sends data until the receive signals till reach a wall and object, and calculate the distance between receiving and signal and sending it, and calculate the distance between sensor and object. Here are the 2 wires for trigger and echo, and other 2 wires for a voltage and the ground. I have 2, and we use a Bluetooth module HC06 to connect our mobile to the car and give it command for forward and backward and right and left. And we use a buzzer here for if it detect an object, buzzer will make tune. Now we will look at the code. We use a motor driver for connecting 4 wires. Each 2 wires connected together through a pin, one in 1 and in 2 and in 4. One for go forward and one for go backward, and for go right or left. If you want to go right, we'll make right wires move, so and left wires stop. The car will rotate, and in the left so also. That's what in our task we use delay 20 ticks. We use BDMS to ticks to convert it from millisecond to ticks. And here we read the analog values from joystick. It's depending on its X and Y position, we change the gear state. Serial and not available is initializing for a Bluetooth module. We associate it with TX1 and RX1, and here we calculate the distance depending on array we initialize for above. And now we're checking buzzer is on. We connect on the distance. We check if it is greater than 50, so the sensor is reading value object. We'll make a buzzer on, tune and change its flag. This method is used for reading the sensors, and we
In this feature, the second feature, we are displaying everything on the LCD. We're displaying the temperature, the date and time, the gear state, and also the night detection, whether it's bright or dark. So here we have the temperature sensor, the DHT temperature sensor. We read the temperature from the DHT and put it in a float called temp. Then we write the temperature we read and put a C beside it, which is degree Celsius.
Hello everyone, we will discuss the sensors we use to display the data we have on the LCD briefly. Now we will start with the LDR sensor, which is used to detect whether it's bright or dark, and the LED will be on if it's dark. So now we will darken it. Now the LED is turned on. Here we have the RTC bus, which is used for displaying the date and time info on the LCD. Here the pins are SCL and SDA and VCC and ground, which is connected directly to the Arduino board. Here in the LCD we display the date and time. Here the date and the time, and also by using the LDR sensor we display whether we detect whether it's dark or bright, and display dark if it's dark and light if it's light. And here we display the gear state we have also. Here we have the code for the RTC module and displaying the date and time on the LCD. Here is we display the hours, and print it on the LCD. Also, we print the minutes and display it on the LCD, and detect whether it's check whether it's AM or PM and display it. And also for the time date displaying, we display the years the same way as the date and print it on the LCD. And here is a night detection sensors, LDR status, which reads the night detection pin, which is initialized in the start of the code. And here is the checking of the LCD status, whether it's night or dark. If it's dark, we display D on the LCD, and if it's bright, we display L on the LCD. And also we display the gear state, the LCD.
We have here our MP3 and our 3 buttons, one to play and stop, and button for next, and button for previous. And here we have our speaker to listen to the music. We have the SD card to put our music in it. بس كده. We will try to start our music. Next song, the previous song. Okay, we have our task music, which is responsible for the MP3. It have methods to control the buttons. First, we have method play first. We set the volume to 200. We have void pause, play next.
We use semaphores with the MP3 player so that we can press a previous or next if you're not pressing playing already. So if it's on pause, if you press play a previous or next, there's nothing happening. In our code, we created the semaphore. Then when we press play, if the flag is true, we pause and we take the semaphore so that you can't press previous or next if it's not playing. Then if it's playing and we want to pause it, we put the flag to true, then we call play method. Then we give the semaphore so the previous or next can take it. Here is the song working. If we decided to press previous or next, everything's working. So the song is playing. If you try to press previous or next, we go to this code. If we press next, We try to take the semaphore and wait for only 5 milliseconds so that the code is not blocking. If we could take the semaphore, we play next, then give the semaphore back for anyone who wants to use it. So now after we discussed all our features, we discussed the first feature, which is the obstacle detection, the second feature, which is displaying everything on the LCD, and the last feature, which is sound system using MP3 player. We gave you a brief description about our project, and that's it. Hope you enjoyed. Thank you.